if you start with a ring with fewer carbons than you end up with, that indicates you'll have to do an alkyl shift where it'll expand the ring. And I'll show what that is. So that's this, right? We start with a ring with 5 carbons, and then this ring has 6. So we'll know there's an alkyl shift involved. So this one
You start with a
starts with, since alcohol isn't a good leaving group, it's gonna protonate first and turn into, yes, H2O plus.
So wait, OH is not a good living group? Or it is?
It's not a good leaving group. So this will be a good leaving group. So this is the loss of the leaving group. And then we'll form a carbocation, right? When it leaves. Sorry, keep trying. Once this leaves, there'll be a carbocation there. And then we'll want to do the alkyl shift. And what that's going to look like, because this will go here, right? Or it will go like this. To keep track. So I like numbering it, so 1, 2, 3, 4, and it doesn't matter what the numbers are, as long as you keep it consistent in this one. So 2 is now here. Because, yeah, 2 is there. This methyl we said was 4, 5. That'll be here, down here, and then you just follow that. And the carbocation, if it's on 2, it'll move to 3. So in this one, it'll be here. And then this water is going to attack it there, and it'll turn into this.
Wait, that comes from that water came from the hydroxide, right? I mean, sorry,
Yeah.
yeah. It just left the ladder behind.
What was that?
That's the same,
Oh no, I think it's just like,
or that's part of the solvent.
yeah, it's part of the solvent.
What's an alkyl shift? Did you shift to hydrogen?
This whole thing kind of shifts here. So when you shift to hydrogen, that's the hydride shift. But for alkyl shift, like this whole side of the ring is gonna go here. So we're going from a pentane to a hexane, because that's what we were given, right? Is this will turn into this. Yeah, so always make note of that when you're given mechanism problems. Like make sure if this one has less carbons than this one. If it does, then you'll know you'll have to do an alkyl shift. Yeah.
What happens to the bond between 3 and 4?
Oh, shifting, I numbered it so that we know where to move the carbocation. But once this goes here, I'm just like kind of showing how the ring expands. And then in order to know where this carbocation moves, that's why I numbered it. So that
So basically the bond between carbon 3 and 4 just opens up
yeah,
right there,
it opens up.
and
So,
then
like,
lets one more of the 2 and 3 into the sequence as it shifts down.
yes.
Okay.
Wait, what type of mechanism is this? SN1 to E1?
This would be E1.
So there's no heat, right?
Because we're kicking out this.
Because it's polar probe. I mean, in general, you know if there's an alkene here, and there isn't one there, right? So we know it'll be elimination. And this is a clinic solvent. So it's between SN1 and E1. And we know it's elimination, so E1.
But it doesn't have heat though, that's what.
I don't think that's necessary. Maybe it's not written.
Maybe it's just.
It's just showing us the beginning. Wait, so now that the H2O goes back there, then what happens?
It's elimination, so it'll turn into a alkene.
But what is it taking the nitrogen with it?
Wait 1 second. Oh, yes. 1 second. My bad. So it'll take this hydrogen. Yeah. This will go here. Yeah, sorry guys. Elimination, yeah. Yeah, and we could have also taken these hydrogens, right? But since we want the alkene to be here, it'll attack this one.
Why is the carbocation on a secondary substrate instead of the one on top?
Oh, in this case, we're not trying to like make it more stable. We're just trying to go from this to this. Yeah.
What do you mean by no more than 5 steps?
I remember he had mentioned that, like on his exams, the mechanism problems shouldn't be more than 5 steps. So like this one has 1, 2, 3, 4. Yeah.
The biggest we did so far is 3.
Okay. Yeah. So if you have like a lot more than that, maybe something isn't right.
Oh. No, that's not at all. I think he was only talking about us making the product. That's a classic mechanism, and that was what we for when we have the product. I think this would be considered step 1 mechanism.
they're both hexanes, right? So we won't have an alkyl shift, but we noticed that this one has a double bond. So does this one, but it shifted, right? When you see that, when there's like a shift of a double bond, it'll indicate that you'll have to do resonance. Resonance is involved. So in this case, BR will be
That's a resolution question.
And what can shift the double bond, right? Bond to bond?
Question. It's not from, because the questions are not like that, like they don't get like another structure.
They don't give us other structures.
Like this one?
Yeah, they don't give none of the questions we
They
have on
just
the
use
exams.
the first one and then we
Yeah.
do the rest.
Are you looking at, wait,
The exams.
for mechanism?
There's two types of mechanism. One is we're given the answer and we have to do the steps. The other one is we have to do the steps and the mechanism.
Oh, yeah, for these problems, it's only one on for each exam.
Look all the way to
It'll
the
say
end. It'll be like
mechanism.
P6.
This one.
I can't see it.
Isn't this synthetic?
What does the question say?
Yeah, it'll say it.
Yeah, show the synthetic root to you.
Yes, that's synthetic, that's right.
Oh.
So then this exam doesn't even have that question.
What is the one before that say?
Can I see?
Yeah. Have the other exam just in case.
It's right here. It's this one.
Which one? Oh. This one here.
Okay, so this bond will become a bond there.
Yeah.
And carbocation is one. Then H2 into an attack. And then to deprotonate, we're always going to just use water. Again. There. Get that. This one was like 3 steps. So this is deprotonation. Since this one has OH plus after this water attacks there, to
How come-
deprotonate it,
How
we're
come
gonna take
attacking?
this OH.
How come attacking a positive charge with an H2O makes it an OH?
In this case, it's nucleophilic. So it's just gonna replace for the carbocation.
I don't know what that means.
This is for SN1.
Yeah.
I don't know what that means either.
SN1, for SN1, the nucleophile is just gonna replace the leaving group.
Again, why does the H2O change itself into an OH? Does the
Like
H2O,
straight to an OH?
huh?
Like straight to an OH?
Because it has a formal charge and stability. Remember we were like, how many bonds? The full valence shell is 6, minus 5, minus whatever. In that case, it's minus 3, minus 2, so it still has plus 1. So H2O electron is just going to take the hydrogen off to make it more stable.
So basically the H2O donates a hydrogen.
So if that was that there's H2O in the entire thing, another separate H2O would take that hydrogen. And then the OH becomes OH.
So this one is taking this hydrogen, and then it's left with OH, right? And neutral.
The OH
OH would be a negative, therefore adding the negative into the positive will make it neutral. Okay. So we just, okay, that H2O would be it's still in the solution, right?
Yeah.
Okay,
There'll be
that's why
plenty of
there's an abundance of
H2O.
H2O,
Yeah.
okay.
And that arrow, when it's just one thing on top, we assume it's both the reagent and the salt.
Ah.
Yeah, those are the two types I saw. Either you'll have to do an alkyl shift where you'll notice that the starting has less carbons than the final product, or resonance where the double bond will be in a different place.
No, not in class. This is my first time seeing.
Synthesis.
Synthesis.